Okay, this video is going to be over scientific notation and significant figures. So first we're going to talk about scientific notation. And scientific notation is basically just another way to express a number. In chemistry we use a lot of really big numbers and really little numbers, so we don't want to have to write a bunch of zeros. So we use scientific notation to make life easier. Alright, so if I have 10 squared, what is that? Well, that's equal to 10 times 10, and so that's 100. So if I have 2.47 times 10 squared, well, that's the same as saying 2.47 times 100. And so that's equal to 247. So these two numbers right here mean the exact same thing. All right. And so basically the quick way, if I have 2.47 times 10 squared and I want to express it in regular notation, I would just move this decimal place right here, move that decimal place over 2 places because I have an exponent of 2. And so if I move it over 2 places, 247, right? Okay. All right, so with negative exponents, it's a little bit different. And I'm going to explain it to you so that you can understand what you're doing and why you're doing it. All right, so if I have x to the negative 1, x to the negative 1 means you have the inverse of x, right? So this is equal to 1 over x. Or if you have x to the negative 2, then that means you have 1 over x squared. Those are equal. And so a negative exponent means that you're dividing by that number. So if I have 8.46 times 10 to the negative third, then that means that I'm dividing by 10 to the third. Okay, so this negative exponent drops it down in the denominator. So this is equivalent to saying 8.46 times 1 divided by 10 to the third, which is 1,000. And so if I take 8.46 times 1, I get 8.46 back. And then I'm dividing by 1,000, which means that this number is actually equal to 0.00846. So all I'm doing is moving this decimal place right here back 1, 2, 3 places, and then putting 2 zeros there. So these two numbers right here are the same number, they're just written differently. Now our exponents in chemistry a lot of the time are much bigger than 3 and 2. They're like in the 20s. So that's why we want to use scientific notation. So in your assignment that was given today in class, you had some numbers that you had to write in scientific notation. So let me group all this stuff together so I can move it all up. So if I have if I have 0.000138 and I want to write that into scientific notation, then I'm going to move the decimal place to where there is only one digit in front of the decimal. So I'm going to move it 1, 2, 3, 4 times. And so it's going to be 1.328 times 10 to the negative 4. Okay? And so that's the number expressed in scientific notation. So let's try another one. Let's try 1, 2, 3, 6, 4, 9, 0, 0, 0. So if I want to write this in scientific notation, then I'm going to have to put the decimal to where there's only one digit in front of the decimal. I can't just put it anywhere. I need to put one digit in front of the decimal. So I'm going to move the decimal all the way back to here. And so we have an invisible decimal at the end of the number. So there's 1, 2, 3, 4, 5, 6, 7, 8 places that I had to move. And so that's going to be 1.23649 times 10 to the 8th. And so this is a positive exponent because this is a large number, and this is a negative exponent because it's a tiny number. So remember, a negative exponent, you're actually dividing by 10 to the 4th. And so that would make this number being divided by 10 to the 4th, making it very small. And this, you're just multiplying by 10 to the 8th, so that makes this number really big. All right, so significant figures. If you are learning this for the very first time and you have never taken notes over it, I suggest you pause the video right now and write this into your notes so that you have it there. Because otherwise you're going to be just trying to write these down while I'm going through examples and you won't catch what everything means. All right, so the first rule, all non-zero digits are significant. What that means is any number that's not a 0 is significant in a measurement. And so if I have 746.8, that means that this number has 4 significant figures, right? Okay. And if we look at the next one, leading zeros are never significant. So if I have a number like 0.000896, then that means leading zeros are numbers in the front, zeros in the front. So these zeros are all leading, right? So they're not significant. So this number only has 3 significant figures. All right? Trailing zeros, number 3. Trailing zeros are only significant if a decimal is present in the number. And so if I have a number that is 200.0, then that means that that number has 4 significant figures in it because there's a decimal present. If I had just written down 200, so I'm going to write down a 3 here because we're still on rule 3. Rule 3. Okay, so if I had just written down 200, then there would only be 1 significant figure here because there's no decimal place telling us that these 2 numbers are significant, that they have been measured correctly. All right? So significant figures are a way to represent how accurate your measurements were, how good the device was that you used to measure the numbers. If you want more information on that, I would be happy to sit down with you, but I'm not going to cover that in this video. All right. Number 4, sandwich zeros are always significant. So rule 4. Rule 4. So if I have a number that looks like 100.09, this number has 5 significant figures because these zeros are all sandwiched between non-zero digits. All right? And then the last rule, exact numbers have an infinite number of significant figures. That means that if I count, okay, so if I count a certain number of, let's say, pens, and I've got 29 pens. I don't have 29.1. I don't have 29.000002. I have 29, exactly 29. So that means that 29.0000000000, and it would go on forever because it could never be a fraction. It could never be part of a number. And so that means that I have an infinite number of significant figures if I've counted it. This is also the case for unit conversions. So, let me group that. So if I have 12 inches in 1 foot, then that's an exact number. 12 is exact. 1 is exact. 60 seconds in 1 minute, that's exact. It's not rounded. So it's 60.000000 forever and ever and ever. And so if I needed to know how many significant figures were in 12 inches is equal to 1 foot, there would be an infinite number, and there would be an infinite number in this number 2. Okay? All right, so let's do a few more examples. I'm going to move all this up. All right. So we're just going to see how many significant figures are in each one of these. So let's say that one, and then we'll do that one. Okay, so in this first one, how many significant figures does this have? Is this 0 significant? Yes, because it's sandwiched, and sandwiched zeros are always significant. Is this 0 significant? Yes, because it's a trailing 0 and a decimal is present in the number. So that means I've got 1, 2, 3, 4, 5 significant figures for this number, or that measurement. All right, number 2. Is this 0 significant? Yes, it is sandwiched. Is this 0 significant? Yes, because it's trailing and we have a decimal present. So then that means that there are 4 significant figures. All right, number 3. Are these zeros significant? No. Number 2, rule number 2 says leading zeros are never significant. Is this 0 significant? Yes, because it's sandwiched. So that means that this has 3 sig figs. And then number 4, is this 0 significant? No. Trailing zeros are not significant if there is not a decimal present. So that means that this only has 2 significant figures. All right, so now we're going to round these numbers to 3 significant figures. So the first one, I'm just going to write some down here so we can do some examples. So let's say I've got okay, and then let's see. All right. So in this first one, I've got 62.449. So I need to round to where I only have 3 significant figures. Well, as of right now, this one has 5, right? All of these digits are significant. So if I want to round to 3, I'm going to count. I've got 1 significant, 2, this is my 3rd significant digit right here, this 4. So I'm going to round to there. And so what I end up getting, all you do is you look to the number to the right of the digit you want to round to. It doesn't matter what else is over here. You only look right here. And so since this number is 4, this number stays where it is. And so rounded is going to be 62.4. All right, number 2. So I will need to round to 3 significant figures. So this is my 1st, 2nd, 3rd significant digit. And that 0 is significant because it is sandwiched. All right, so I'm going to look right over here to this 8, which means that 0 has to round to a 1 because it's 8 is greater than 5. So that means I'm going to have 721. Now I can't just say 721 because that's not equal to 7,200, right? It's nowhere close to it. We can't change how big the number is. We can just round it. And so I have to put a 0 there. Is that 0 significant written this way? No, because there's no decimal place, and trailing zeros are not significant if there's no decimal, right? All right, now this one is tricky because this number 3 only has one significant figure. And so to write this to 3 significant figures, the easiest way is to put it in scientific notation first. And so this number written in scientific notation is going to be 6.10, I'm sorry. It's going to be 6.00 times 10 to the third. And I just dropped a 0 so that I'd only have 3 significant figures. All right, so this is equivalent to that. All right, and then on number 4, this is the first, second, third significant digit, and so I have to round that 6. So I'm going to look right next to it. The 7 is greater than 5, and so this number has to go up. And so it's going to be 0.00497. Now remember, these first zeros, the ones up here, are not significant because they're leading, and leading zeros are never significant. Okay, and then the last thing we talked about today in class was significant figures and calculations. And this is what you're really going to be using for the majority of the year. So addition and subtraction, if I have numbers like 14.6 plus 8.932, and I add these together, in math class you would get 23.532, and it would be right in math. But in science, we have to look at the digits that are given to us. And right here is where the cutoff is, because we don't know what these were. Whatever we use to measure this value right here could not measure the hundredths and the thousandths place. Whatever we use to measure these values right here could. So we can't really say this was 3 and 2 because it might not have been. It could have been, these numbers right here could have been 9s, they could have been 1s, they could have been anything, and it rounded to 14.6. So we cut off the answer right here. All right, and so it says round the answer to the least number of decimal places. If you looked at this number right here would only have 1 decimal place, or 1 number behind the decimal. And then this one right here would have 3. So the least between those two is 1. So we're going to round our answer to 1 decimal place. So I look to the number to the right, it's a 3, and so this number stays what it is, and so my answer would be 23.5. Okay? All right, and then so last but not least is multiplication and division, and this is by far the most important thing that we will use this on, because in chemistry we multiply and divide more than anything else. All right, so if my numbers are 32 times 500, all right, the answer to that is 16,000. Now, I'm going to look and I'm going to see, okay, this one has 2 significant figures, and this one has 1 significant figure, because these zeros are not significant. There's no decimal place saying that they're significant. So I have to round my answer to 1 significant figure. And so this digit is the first significant figure, so I have to round to that digit. So I look right next to it, that's a 6. And so the 1 rounds to a 2. Now I can't lose how big the number is, so I have to fill it in with zeros. And I don't want to put a decimal place because I only want 1 significant figure in my answer. All right, so let's try another one of those. All right. Let's say we have 4.97 times 20. All right, so that's going to be 99.4. Does that sound right? All right, so that's right. And so we're going to say that the 20 has a decimal place here too. Okay, so, and you can put these in a calculator. You don't have to do them in your head. So now what I do is I look up here and I say, okay, this one has 3 significant figures, and this one has 2. So this 0 is significant because a decimal is present. So we're rounding to the least number. And so the smaller number is 2. So we have to have 2 significant figures in our answer. And so this is the first one. This is the second one. So I'm going to round to that digit. The 4 is less than 5, so the 9 stays. So my answer is just going to simply be 99. So this comes from this device not being good enough to accurately measure past the ones place. And so you can't report a number that has decimal places after that. It doesn't make any sense. Like I said, if you want some more information on that, I would be happy to show you accuracy and precision and how all that plays into this. But you basically need to know how to use significant figures. So this will all be on the first test. And after that, anytime you use significant figures correctly in a calculation, I will give you bonus points on the test. All right, so come in if you need help. Otherwise, that is everything from today.